Hello, fellow 6BL students. Today I'll be going over the process of caramelization. The decomposition of sugars is known as caramelization, which begins at its melting point of 367 degrees Fahrenheit. Once table sugar reaches its melting point, which can be between 365 to 380 degrees Fahrenheit, the molten sugar becomes a dark brown color, and after the addition of a few ingredients, becomes the well-loved sticky topping, caramel. The addition of butter, cream, and vanilla are for flavor and texture purposes, yet the sugar component is very fascinating through the lens of chemistry. What is exactly happening during the caramelization process? Well, when sucrose, which is what makes up white table sugar, and water are heated together, they break down into fructose and glucose. These new volatile molecules are known as aroma molecules, and for example can be such as diacetyl, which provides a buttery rich flavor, maltol, which provides a toasty undertone, or furans, which give off a nutty flavor. Here is a visualization of the sucrose inversion, which occurs with the introduction of heat and water. Sucrose cleaves into glucose and fructose, which give off side products of aroma molecules such as ethyl acetate, diacetyl, maltol, and furans, which can be seen to the right. After these new aroma molecules are synthesized, oligomerization occurs. This is prescribed by the dehydration of hydroxyl and hydrogen groups on both the fructose and glucose molecules, which then fuse to form a wide variety of compounds. Rearrangement can also occur in this process, which results in almost an endless supply of distinct structures and isomers. This is where caramel's robust flavor comes from, these hundreds of synthesized aromatic compounds made from these condensation reactions of sugar. The browning process that we see in caramel is provided by a set of independent reactions known as Maillard reactions. Here is an example of the Maillard reaction. An open form of glucose undergoes a dehydration reaction with an amino acid that is free in order to form a product. Some people think that the browning process of caramelization is specifically linked to the dehydration of sucrose. However, it is an entirely independent reaction. This browning also extends to foods like meat and bread and is not just for caramel. All right. Let's get into the procedure of things. So we will first heat 150 grams of white granulated sugar and 60 milliliters of water in a medium saucepan over medium heat while stirring. This is continued until the sugar has dissolved and the reaction mixture has become a golden colored liquid. Immediately after all the sugar crystals have dissolved, 58 grams of butter is carefully stirred for about 2 to 3 minutes or until completely incorporated. And don't be alarmed if rapid bubbling occurs, this is normal. 120 milliliters of heavy cream are then added and slowly drizzled into the reaction mixture, and rapid bubbling will probably occur again. After the cream is fully incorporated, the caramel was brought to a boil for roughly 1 minute. This caramel was then removed from the heat, 5 milliliters of vanilla extract and 1.5 grams of salt were whisked in. The final mixture was then allowed to cool at room temperature and chilled for at least 15 minutes before using. Here is the caramel sauce recipe that I am using for today's experiment as detailed previously. You can refer back to this if you would like to make this yourself or if you had any confusion about the procedure. I got this recipe from a good friend of mine who is an excellent baker. Let's get into the kitchen! Alright, I'm currently doing step 1 of the procedure, which is adding 3/4 cup of the granulated sugar along with a 1/4 cup of water and letting it heat over medium heat while stirring. The temperature right now should be around 367 degrees Fahrenheit, which is the melting point of the sugar crystals or sucrose. Alright, now our sugar mixture has become a light brown or more of a golden color, so I will be adding in the butter and stirring for about 2 to 3 minutes, and it is okay if bubbling occurs. See you after this stuff. All right, it's been around a minute of the butter being added, and I'm already starting to smell that buttery flavor, so I can assume that that is thanks to the diacetyl aromatic compound forming, as well as some of the other ones we discussed in the pre-lab. All right, it's been 2-3 minutes since the butter's been added, and I will slowly stir in this heavy cream. All right, the heavy cream has been incorporated, and so I will now be letting it boil for a minute, and we'll check in after that.
Here's the final product, a nice brown color with a bunch of aromas from the new aromatic molecules that were created. And yeah, there we go. Tastes great.
To make sure that this caramel tastes good, I'm having my housemate Heidi here be a taster for us. This is what the cooled solution looks like, and let's hear it straight from Heidi. Is it good? Do you taste the diacetyl and the maltol and all that?
Delicious.
Okay, it looks like we successfully synthesized some caramel.